We are back with the second of our two-part episode on the Tech Ed podcast with Tom Kelly, the Executive Director and Chief Executive Officer of Automation Alley. If you missed the first episode, you want to go back and listen. We had a great conversation about Automation Alley, around readying the workforce, around whether or not the existing manufacturers here in the United States of America are ready for Industry 4.0. And if not, what should we be doing about it? In this episode, we are going to go deep into Industry 4.0 technology, including additive manufacturing and blockchain. We are going to talk about the startups that are just getting going in the world of Industry 4.0 and the challenges that lie in front of them and the amazing technologies that they are adopting. We are going to talk about partnerships between education and industry and Automation Alley, all on part two of this two-part episode. Welcome to the Tech Ed podcast, where we visit with leaders who are shaping, innovating, and disrupting technical education. People who are not afraid to think differently, not afraid to try something new, all with the goal of securing the American dream for the next generation of STEM and workforce talent. And I'll be honest, if you turn the clock back to my manufacturing days, which is now, we sold our last manufacturing company in 2014. But I remember going into high schools and having them tell me, hey, we're going to bring you in and show you our advanced manufacturing department. And then they brought me into like a fab lab with 15 3D printers. And I'm like, wow, that, and they're all printing like heads of Yoda from Star Wars or something. I'm like, that's really cool. But I've only seen 2 3D printers in my life. And at that point, one was at the Product Development Center for Harley Davidson. The other one was at Mercury Marine. I had never seen another one in manufacturing. That's really starting to change. And so I want to get into that a little bit. You've got this Project Diamond, which is focusing on embracing 3D printing technology. And that project describes itself as, quote, the country's largest distributed 3D printing network operating on blockchain technology platform, another Industry 4.0 technology blockchain we haven't even mentioned just yet. Tell our audience about the unique model of Project Diamond, how manufacturers are putting additive to work in the state of Michigan and around the country.
Yeah, so thanks for that. So Project Diamond actually stands for Distributed Independent Agile Manufacturing on Demand. And the theory that we had was, 3D printing is going to go mainstream. And it's been around for 40 years. It's not like this is a new thing we invented. What's changed is the speed with which you can print, the variations that you can print. You can do plastics, you can do rubber, you can do metal, you can do alloys. And the fact that the materials, the cost of the materials and the things you can do with those materials are getting so cheap and powerful at the same time. People don't realize that they think additive is going to go the way of traditional manufacturing, where it's, I have a line, and because the line is expensive and complex and sophisticated, it doesn't change very much. In fact, to change it, it's called retooling, and it's a god-awful mess. And 3D printing doesn't have any retooling. In fact, I can make a part for a knee, and then I can make a part for an airplane, and then I can make a part for a restaurant, and then I can make a part for an auto supplier, all within an hour, right? So this is going to fundamentally blow up what we know about manufacturing. The first part coming off a line in an auto plant costs $1 billion or more, and the next one costs $20,000.
Right.
And they go sell it for 40. But the first part cost $1 billion, right? So you're taking all of that capital risk. So Project Diamond was an effort to say, if the world is going to go down this path, how do we make sure all the smalls can participate in a safe way? And what we said was, we're going to buy you the printer. We're going to make it a production capable printer, carbon fiber, strong as aluminum. And we're going to give it to you. And we're going to give it to 299 of your friends, all right, within a 20-mile radius. And then we're going to create you as a community. And we want you guys to learn about the printer and then teach each other how to use it. And that's exactly what we found when we gave them the printer. See, most smalls will say, until I know what the hell I'm going to do with it, I'm not going to drop $20,000 on a printer. And so you're in this chicken and an egg problem. Like, if I don't get the printer, I never knew what it's capable of. And if I don't know what it's capable of, I'll never buy the printer. So we had an economic theory that if we buy a printer and give it to them, so we invested $10 million in this program, and we are seeing the dividends of that. It's going to take us multiple years to figure that out. But we're already seeing that these smalls, rather than being part of this aggregated big, they've learned how to use them, and they're now making money on the printers all by themselves. And eventually we'll see how we can stitch it together. And that's where the blockchain comes in.
So I think about traditional manufacturing versus 3D printing and then applications for additive. And, over the last 5 to 10 years, what we've really heard and talked a lot about are people think, well, when is my 3D printer going to replace injection molding, or when is it going to replace machining? And that's one question that I want to ask you here in a moment. But the other thing is, the last 5-10 years, end of arm tools for robots, work holding, fixtures, prototypes, armatures for holding sensors and devices on production lines, those kind of applications. Is your sense that that's where it's been? And then if I'm an injection molder, if I'm a contract machining company that's looking over my shoulder and saying, when is additive going to step in and become a replacement for what I'm doing? Are we getting anywhere close to that? Give me your sense of that question.
It's tomorrow, and it's a million years away.
Okay.
Right. It's because it's so specific to the products and the industry. So let me give you an example. So one example is there's a company called Relativity Space. And if your audience doesn't know about them, go check them out. It's Relativity Space. They're trying to build an entire 3D printed rocket all in one go, right? So the traditional model is there's 3,000 suppliers making 30,000 components, costs $180 million to build a rocket, and it costs $60 million to blow it off into space. Relativity Spaces say, and it takes 6 months to make it, or 12 months. Relativity Spaces say we can make an entire rocket in 30 days for $10 million using 300 components, all of which we source ourselves internally. Think about if that actually, by the way, they're a well-funded startup doing this, right? Their first rocket is built. They've built 52 rockets. No two have been the same.
Wow.
The 53rd is the one they've taken to NASA, and they're blowing it off in this quarter. So they're actually blowing it into space this quarter. So think about that. What does that do to the entire aerospace industry?
Yeah, totally disruptive.
Right? It's not like, well, I'm a cog in the wheel. It's like, oh my God, the whole aerospace industry for rockets just changed. Now Boeing has survived because they'll look at that technology and say, oh, we'll just replicate that. Right? And they'll be able to. It's not like it's not rocket science for the 3D printing. It's just they invested in the chutzpah to do it, to say, we're going to try and do this. And so it's that kind of thing. There's another example where GM just built 20,000 Tahoes that they needed to ship. And they could not ship them because they had a part problem with one of their manufacturers. So what did they do? In 3 weeks, they 3D printed 60,000 parts that were needed for those. It was 30,000 cars, 60,000 parts for those 30,000 vehicles. You may have heard about this story. And in 3 weeks, they had all of the production done on the vehicles out the door. That's the dam breaking, right? Because they just demonstrated that, well, wait a minute, maybe I don't need to build $1 billion factory for one part. Maybe if I do all my financial calculations, even though my material cost is higher per part, I don't have any tooling. And by the way, I don't have to carry that tooling. I can ship this printer to Napa and they can print that part forever. And I don't have to have any parts in inventory. When you do the math on 3D printing as a holistic value chain, you're going to see that it really doesn't make a lot of sense for a lot of parts, right? I can give you more examples, but those are two really fascinating ones that talk about the disruption that's coming.
Yeah, those are really fascinating ones. And especially when you think about what's taking place in, to your second point with Tahoe, with Chevy Tahoes. I own two, by the way. I have a 2011 and a 2017.
Maybe you have the little seal that's in the back there that keeps the water out of the lift gate.
Yeah, for sure. Absolutely. In fact, I know the part. And so big fan of Chevy Tahoes. As some of our listeners know, my father-in-law actually worked on the line at GM for 33 years. And so a big soft spot in my heart for General Motors, and they were a customer of our manufacturing company as well. But you think about this day and age of supply chain issues that we're dealing with. And in that particular case, it almost, we didn't talk at all and don't need to necessarily about what the unit cost of each of those parts are, whether you're, machining or injection molding it, or you're 3D printing it. It may be more expensive to 3D print, but if you can't get it any other way, and you've got a $75,000 vehicle that can't move off the lot until we have that part, it almost doesn't matter what you pay for what the incremental cost of that is. So really, really interesting observation. And then the rocket one, just thinking about the disruption that's taking place in aerospace.
One of the things I should add, Matt, that I think would be valuable for your listening audience is, so our 300 Project Diamond manufacturers, what they're doing is a lot of their manufacturing machinery has gone out of warranty, went out of warranty decades ago, right? And they're now 3D printing their own replacement parts, right? Now think about that. What does that mean for the channel? Because a lot of manufacturers exist on the aftermarket profit, not the profit of the initial runs. They wait for the aftermarket, and the aftermarket says, no, I don't need your parts. I'm going to buy it. I'm just going to reverse engineer it myself. And we're seeing that over and over and over again in our small manufacturers. They're just printing what they need for their shops.
Absolutely. I'm sure you were at Automate this year. I have to believe, based on where you're located, that you were there. And I spent 3 days there as well.
We love those guys.
Yeah, it was a really great show, a fascinating show. But one of the things, I spent a lot of time in the Fanuc booth and a lot of time in the Creaform booth. And Creaform found a way to put, a scanner on the end of a 3D robot. And when you start thinking about reverse engineering for additive and being able to 3D scan a particular part using a scanner, output that to an STL file, massage that STL file, and then print the product literally on the same day. Certainly wasn't the manufacturing world that I was in.
And it's probably lights out.
Yeah, exactly.
Because the design work is being done by an Autodesk, the regenerative design work.
Yep, absolutely. Or Mark IV Jaeger is the other one that I've spent a lot of time around, which is just fascinating technology in terms of design for additive. None of those companies, by the way, pay us a penny for touting their products, but it's just interesting applications of those technologies. I want to touch really quick on blockchain. You mentioned that, and I mentioned it in the question. When I think about blockchain, Tom, I think about non-fungible tokens. I think about cryptocurrency. So just a really kind of layman's example of how blockchain comes to bear here on the Diamond project.
Yeah. So, well, fair disclosure, Matt, it's a work in process. So we're not running blockchain on the network the way you would think. It's not like exchanging Bitcoin or anything. But what we are working on, we are building this blockchain network because we need things like digital ID. I need to know that printer is where it's supposed to be, who owns it, undisputable, right? And that's great for blockchain. We need digital recipes, right? So if you're going to have distributed manufacturing, then the recipe that everybody gets has to be exactly the same. And there has to be a way that recipe can be validated so that it's not so much the part, it's the part plus the recipe that makes a complete, valid forensic file, right? So we have to work on digital recipes, and that's a blockchain initiative. Digital rights management. So if I'm Boeing and I say, I got a great part, I need to know if I put it on your network and it goes to the right printer, the digital ID assures that it's not somebody spoofing and they're in China waiting for the IP to be downloaded, right, in real time, that my IP will be safe. And even though the printers are distributed, I can feel a sense of safety that my IP won't be destroyed in the process. And then lastly is the quality process itself. So what's happening in 3D printing is they're starting to get sophisticated. We're saying, I'm going to lay down some material, then I'm going to take a laser picture of it, then I'm going to lay down some, and then take a laser picture. And what it gives you is a perfect representation of what that part was when it was made. Great for liability and warranty claims, right? It says we know down to the layer by layer level, this part was perfect when it left our factory. So don't tell me I was the cause of your downtime or whatever, right? And that needs to get stored in a blockchain. Think of all the files. And what's nice about Project Diamond is, so we have 300 today. Our goal is to add as many 3D printing manufacturers that have 3D printers as want to participate. That should result in thousands of manufacturers. Well, when you have thousands, you have more than enough to run your blockchain. In other words, a blockchain is just a distributed ledger. So if each of these manufacturers has the ledger, that in itself is a very efficient way to do that. So there's lots of fun things happening. I got to be honest with you, I don't know where this is going to go, But we're just pushing the ball. We're like, well, what if we tried to do digital rights on this network? How would we solve that problem? What if we wanted to do digital ID? How would we solve that problem? So that's what this network is all about. And we encourage any of your listeners, talk to us. We don't charge for it. Come on, let's be a part of the family. Let's figure this out.
Absolutely.
It's really, we want to build a network that can sustain any competitive threat from anywhere around the world.
Fascinating. Yeah. And I guarantee you that you're going to generate interest with what you just said, with as many manufacturers as we have tuning in every single week. And as we see additive and 3D printing technology continue to just totally transform manufacturing, it's been fascinating for me to watch from the outside looking in. I think back to, thinking about like a third-party lab that you would take a part to and you would have them, dissect and trying to figure out a failure, try to understand at what point in the manufacturing process that failure took place, or who is to blame, or who had to own the reproduction of that order, or what have you. And I'm not just making that up. I mean, in 30 years of manufacturing, you sit in your fair share of those types of meetings, and now to have the type of technology that can literally look layer upon layer and drive a quality question all the way back to the answer and help you innovate more quickly. And then using things like artificial intelligence and machine learning to build even more quality into the product using that real-time data that's coming off of it. It's just, it almost gives me goosebumps to think about where we are, Tom, in manufacturing today, as this technology just continues to accelerate. And to use that term, you're an Industry 4.0 accelerator, right? Let's talk about what is when you use the term Industry 4.0 accelerator. And I think I read someone, you're the number one Industry 4.0 accelerator in the country. And what's an Industry 4.0 accelerator?
But we called ourselves number one because when we started this up 4 years ago to invest specifically in startups that had technology related to manufacturing, we looked all over the US. We could not find any organizations that focused on Industry 4.0 technologies in that cohesive group like that. There was one in Europe, there was one in China, there was nothing that existed in the US. And there's a reason for that. Most startup communities are focused on software specifically, and they don't want any hardware component of it because they need it to scale rapidly. The only way the VC model works is if you can 100x a company from start to finish so that everybody can get on board and everybody can get a return. If you build a technology that helps a manufacturer QC a process and you got to go to every manufacturer and install that, it's a very linear model, and VCs yawn and say, I want nothing to do with that. So that's why we started the accelerator, because somebody needs to be investing in these technologies. We can't let China run the tables on us for all of this stuff, right? We got to be holding on to our own. So we started this accelerator, and it's been a great ride. And we did this in partnership with two of our friends, Lawrence Tech University and Lean Rocket Lab out of Jackson, Michigan, because Jackson has a deep pocket of manufacturers and manufacturing know-how. And so between Lawrence Tech, Lean Rocket, which Lawrence Tech calls themselves Centropolis, between Centropolis and Lean Rocket and Automation Alley, we really have a good cohesive group, and we help these businesses get started and get them their first customer, right? It's a very powerful program.
It's interesting that you talk about acceleration in the way that you do, and bringing the VC example. Going back to 2014, we were selling a manufacturing company. It was a private equity backed company. And it was really interesting period, because normally when you have a transaction like that, you'll go out to the market and solicit interest. And you may have like 2 or 3, maybe 4, what they call management meetings, where the venture capitalist or the private equity firm, or maybe it's a strategic buyer that comes in and learns all about the company. And you got to, as a leader of the company, you got to put on your big dog and pony show. One of the most fascinating conversations I ever had was as I was driving from our company's manufacturing facility to the place that we were going to have dinner with one of these potential investors. And it was about a 45-minute drive, and tremendously, a name that would probably be recognizable to a number of our listeners, tremendously successful venture capitalist. And he kept driving back to, what is the one thing that will accelerate this business model? And he must have asked me that question, 7 times, 7 different ways, as we say often, as we were talking about that. So this whole idea of acceleration, this whole idea of how do we get leverage, and huge amounts of leverage in terms of business growth. A great example of the Industry 4.0 accelerator and the value that you're bringing. I've spent quite a bit of time in Jackson and also at Lawrence Tech. And great things going on there. A really, really cool institution there in Southeast Michigan. You go into a little bit about the partnership with Lawrence Tech. And I also understand you've got some private company partners in and that feel like this initiative is really, really important. Tell us about both the relationship and then the private company aspect to what you're doing.
Well, the relationship is great because Lawrence Tech they're partners with us on the accelerator. They also have an incubator, right? And that's that Centropolis group. And so it's a nice partnership because what they do they incubate the companies. And when you get to the point where they have the potential to create a scalable model that can actually quickly grow, they can move to the accelerator. So that creates a great synergy in that relationship. And Lawrence Tech, has such great technology just in its own right. I mean, the fact that the things they work on out of Lawrence Tech in robotics, in artificial intelligence, these startups come in and they're able to get nurtured in a whole different way than if we were doing it some other way. And that led to, the partnerships that we have. So let me try to think. We have GM, we have Ford, we have Lear, Magna, Siemens, Whirlpool, Forvia, Phoenix Contact. I could go on. I think we have like 25 industry partners. And the reason why they're all at the table is nobody focuses on Industry 4.0 as a mechanism, right? So if you're in the business of manufacturing, it's a no-brainer to be a partner with us because they want to get that look. And they want to say, is there anything here that I can take and scale into my business, as painlessly as possible? Right. And that's what all the bigs want. They want to be able to scale something very quickly with very little resistance, because we talked about this. I can't remember if we talked during the broadcast here or if we talked pre-broadcast, but about the culture. And they're like, look, I can't fight my culture. You got to give me a drop dead simple solution that boom, it just goes and makes us money somehow. And smalls and startups don't really understand that. They don't understand the complexity of a corporate relationship and what the issues they fight with that you would find ridiculous if you're a small. And a big would say, that's just the way it is. Everything's Machiavellian here, right? You got to understand that.
Yeah, exactly. That was a couple iterations in my career. I'm sure you've been through them as well, where you were, either employed or heavily working with a large Fortune 500 company, $1 billion revenue companies, and it is a totally different world than working for a small to mid-sized business. Every once in a while, in some of the businesses that we run, people are like, do you dream of being $1 billion company? It's like, absolutely not. That's a nightmare. I don't need all of that.
I'd love to sell it
all that
for
red
$1
tape
billion,
and bureaucracy.
right? I'd love to sell it.
Exactly. That would be okay. Yeah. Yeah, exactly. Sell it for $1 billion. But I've always liked kind of the smaller, tactical, small groups of people accomplishing outsized objectives. And you're right. If that's the culture you're in, it is hard to wrap your brain around what it's like to be in a company of, tens of thousands of people where, for good reason, related to corporate governance and making sure they're maintaining the sanctity of their business model, if you will, really important reasons why they are that way, but certainly they are. Which can stand in the way sometimes of disrupting technology, not all the time. But as you look at some of these organizations you're working with in the incubator side of the work that you're doing, incubator is just absolutely fascinating to me. I was at one at Penn State a couple of years ago, and I could have spent a week there just looking at all these different technologies, all the cool things that they're doing. Are there disruptive technologies, companies in particular that you can mention, or technologies in general that you find interesting as part of this initiative?
Yeah, I mean, so there's so many different technologies that we look at. Some of the ones that come to mind, Detect It, they're a company that's involved in artificial intelligence, and they help figure out, the quality process as a manufacturer would run it. Ataza has a really interesting technology. So that in manufacturing for automobiles, the slightest imperfection on the vehicle ruins the paint job. And it's just a nightmare. And they have people that feel with gloves and they're trying to, get ready to put the paint on. And Ataza has this really high definition system that might be able to, and they've been running this as an experiment, this optical quality inspection for paint. It might begin to solve some of that pain for these paint lines that just wrestle with this perfection that's required to get the paint onto a vehicle. Fusion Coolant is another interesting one. They have a coolant where you can get rid of your oils, right? There's always, like, when you're drilling or you're doing some kind of subtractive manufacturing, creates a lot of heat. And so a lot of times these CNC machines will be spitting cutting oil onto the surface. And then it's a big problem to remediate that, right? To try and keep track of it all and make sure it doesn't get anywhere else. And the plant always has an oily smell to it all the time. These guys use carbon dioxide vapor. And it's really fascinating. What's interesting, though, you asked me, though, you said really innovative and disruptive. And what's interesting is really innovative and disruptive, we usually can't invest in, which is the irony. But here we are, we're Automation Alley, we're Michigan's Industry 4.0 Knowledge Center, because we also need a return on investment. So we have to invest in companies that are ready to get to scale. And so we look at a lot of interesting deals and we try to nurture them. But the real disruption, it almost has to be more holistic. Like I talked about relativity space, where they're getting funded to the tune of hundreds of millions of dollars in a tranche. Because when you're really disruptive, you have to build the whole stream to come along with you, right? And so relativity space has to design a whole new way to make rockets, which requires god awful amounts of capital that gets incinerated along with the rocket engine when you're doing it. And if it works, everybody disrupts the industry and you make billions of dollars. So we see a lot of like good blocking and tackling technologies that can go into plants today and be useful. The really innovative stuff we like to talk about, like a relative, but we don't invest in because it's too hard. This industry's already arms crossed. So the last thing we need to do is try and be evangelists on anything.
Exactly. Well, and to try and pick, especially if you're investing capital, to try and pick the one early stage that's going to be the one that ends up hitting the grand slam home run. If we knew how to do this as successful as you've been and tiny amount of success that I've managed to have, I'd be doing something else if I could do that perfectly every time. So before we close up shop here on the Tech Ed Podcast, one last question for you. Question we ask every guest here on the podcast, and that is, if you could give one piece of advice to a high school sophomore as they consider their future pathway, what is that advice?
I would say be curious. Always be curious, and don't be afraid to solve a problem. No matter how big or how small, don't let anybody tell you that you don't know how to solve that problem. Have the courage to go for it, because the world is morphing into a place where creativity will be what's rewarded. And so unleash that creativity, be curious, and don't be afraid. Don't let anybody tell you can't solve problems, because you can. And it's the next generation that is just going to drive this home and say, I'm not climbing the ladder for 30 years through the manufacturing environment to get to the point where I can turn the knobs. I'm just going to go out and I'm going to put you out of business by building my own 3D printing something, because it's possible today.
And the way to do that, as you put it, is to be a curious, courageous, creative problem solver.
You said it better than I did.
That high school sophomore. What's that?
You said it better than I did.
Well, you had a little bit more time. I just tried to contain it to a couple of short words, but really, really valuable words. And speaking of value, I've just gotten a tremendous amount of value out of our discussion here. Tom Kelly, who's the executive director and CEO of Automation Alley, has been my guest on the Tech Ed Podcast. Tom, thanks so much for taking the time. It's been a great conversation.
Matt, I had a wonderful time. Thanks for having me.
Thanks for joining us for this episode of the Tech Ed Podcast. If you haven't already, subscribe, leave a review, and if you like this episode, share it with a friend. New episodes launch every Tuesday, so listen in next week.